the shirt. Okay. All right. So this is the example I posted online. You can download it. Everything I have here should be what's posted. This is a basic example of inputs. I have my canvas. I have a clear canvas button, which actually doesn't do anything because I'm not drawing to the canvas. But then I have a selection, which might hypothetically be the selection you use for your paint program, possibly. And then I have a couple other different types of input declared. What? It's on the bottom of the next module. Input modularized. So in my setup script, I'm going to create a canvas object in the GL context, make a main variable for my instance of main, and then on key down, I'm going to window.onKeyDown, I'm going to send to the key down function. I'm going to add event listener to canvas. I'm going to click canvas handle, which is going to give my position, and then I'll have a selection callback and a button callback. I'll figure out what's going on with the slider. I was playing with that one. I'm missing something silly in the slider. So if I go up and look at what I have set up here, my different functions, pretty much what I had on the PowerPoints. One thing to note is if I was the ruler of the universe, I would make it so that we could have our callback functions in our main class, but we can't. So all of our functions need to be outside of our main class, and these should be the only generic functions you have in this course. Everything else should be in a class. So here I'm setting up my WebGL interface. I'm not really doing a drawing right now. And then here I might have, say, a list of triangles or a list of objects. I would suggest you view that as a list of objects because this is how you're going to do the paint program. And you're going to populate this list of objects with the exception of the one that you're currently painting. So we'll come back to this in a moment, how we access this. Key down, again, the number of the key pressed, you get the key code and the string from Charcode, which is, again, you can download this. This will have both give you the letter in capital form and the number of your key. There we go. The slide handle, don't worry about that right now. I had to figure out what's going on with that one.
So,
yeah?
I'm sorry to ask this, like, in the lesson, but like, the first WebGL assignment, the one that's worth 40 points, were we also supposed to get that turned in? Or was that, like...
that should be disabled. Where are you reading this from?
It has a minus on it. The assignment is overdue. Chapter 2.
Alright, don't worry about that. Why is it not? Okay, hold on.
He hasn't told you to do it.
Okay, I swear I deleted that. Okay. All right. Wait. Was that the participation assignment, or was that the?
No,
That was just the make a free letter or whatever.
Oh yeah, don't do the letter one. Okay, so the really important one that is not really simple, just simple callback is the 2D input. And so here I've fixed my little typo. So I have my canvas.height instead of my canvas.width with an appropriate line. And here I'm going to take the screen coordinate or the pixel value from the top left and convert it into a WebGL coordinate between -1 and 1. And so when I print this out, the X and the Y I'm going to print here are going to be in WebGL. It's very important that you design your code. I would design your code so you assume you're going to pass WebGL coordinates into the objects. Otherwise, you're going to be repeating this code, and there's no point to store the pixel values really. So we're going to assume that we're going to use storing the WebGL coordinates, the vertices. So just assume no matter what you're doing, when there's a mouse click, the first thing you're going to do is convert it to WebGL, and then you're going to figure out where to send it. Then here I demonstrate doing the selected index versus the value. This is going to be 0 through whatever number of the list, and this is going to be the value that the user sees. And then here's the button handle, so you can click the button. So you can click the button. So really, really simple input. Again, hopefully review, except for perhaps the mouse input, which is a little bit different than what you would probably have done in web design. So launch this in Chrome. And now, so I hit clear canvas, it says you click the button. If I hit the first option, I get the option 0. This is the normal way how drop downs respond or lists respond, and then I get the value as circle. And I can do it for the other two. If I press anything, or if I press any key, I will get some sort of response. If you see this character, that means I'm hitting the shift key. So, but I can type lowercase, it's still uppercase. So I can get the key code, which is HTML key code, which I think is capital ASCII, if I remember right, and then I can get the actual letter. So in this case, you don't have to worry about lowercase letters, and you can access what key you're pressing. The arrow keys do not work with this callback though. Oh, yeah, they do. So, but they give me some strange characters. So I'm not sure what's mapped there, but you can map that to the arrow keys as well. So this will give you kind of like, again, the basic input. Now, the one I really want to show you was the mouse input, because now if I go up here to the corner of my canvas, I get -9.89, so I'm not quite. See how close I get to that. Oh, a little bit off. There we go. I got 0.93, 0.94. So -9.3, that's very, very close to -1 on the left, and 0.94 is very, very close to 1 on the top. So you see that corner is working. And then if I zoom down to right around there, I should have a border on the canvas that would make my life easier. But I should see oh, I somehow got lower than -1. That's probably because my canvas. I don't look at that. That might be because it did include the top buffer on the web page. I thought it would only include. It should start from the corner of the canvas, but so I get 1 and I get -1 essentially, very close to -1. So this coordinate conversion will work for converting 2D screen coordinates into WebGL coordinates for my canvas object, or close enough. The human eye is not going to be able to tell if there's any floating point error or any. The human eye is not going to be able to determine it. So you can use that as a way to do your paint program. Now, again, the paint program. Please design it on paper. Think about flowcharts, think about class diagrams, use whatever tools you've learned about software engineering before you start coding it because it will save you hours, if not days, of debugging. So, going about how, just looking at the requirements in general, if I click on the canvas, I want to create an object, and the objects can be selected from HTML. Each object, how it functions, is going to be a little bit different. So if I select the circle, then I'm going to have to extend, I'm basically going to have a 2-point selection. I select the circle, that's the middle of the circle, and as my mouse moves away, I want to see the outline of the circle as it's getting bigger, and then I want, as the mouse moves closer, I want to see the outline get smaller, and when I click again, where that outline is, I either draw the outline or the line, or I draw the fill, or the triangle. Likewise with square, square is in the top left corner, bottom right corner, right? So 2 clicks for that. Triangle is going to be 3 clicks, so 1 click, 2 click, and wherever my mouse is moving on the 3rd click, I'll see a temporary triangle outline drawn. And I click the 3rd click, it'll finish drawing the object, and then I will add that object to the list. So, how I would do this is, one thing you have to understand is if I'm currently drawing the shape, I'm going to have to rebuffer everything. Rebuffer that particular shape. If I'm currently drawing a shape, I'm going to have to basically clear the screen and redraw all my existing shapes, and then draw the new version of the outline of the shape. Now the outline of the shape, the vertices are going to be changing or being added to more appropriately, so I have to buffer that every frame, but I don't have to draw. That kind of makes sense? Thinking about a little bit. So, what I would do, and to make your life a little bit easier, you may have, if you wish, a global variable for mouse X and mouse Y in WebGL. And the reason this is necessary is you're going to temporarily add the current position of mouse X and mouse Y in WebGL to the shape that's being drawn's vertices. Then you're going to remove it because you want it, as if the shape, as if that current position was the final position of that vertice. So when you update it, you see this outline following wherever your mouse is going. So if you, to make your life easier, you can make a global variable for your mouse X and mouse Y. And what you would do is then you'd have mouse X, mouse Y equals 0, globally defined here, and then in your move mouse callback, you would just update those variables and it would be in place on canvas. So it'll make your life a little bit easier on that front. Does that make sense? All right. So, now each shape is going to be a little bit different. So you'll have to figure out how you want to do that. But I would say class, we'll call this rectangle. I'm not going to give you all the code, but I'll give you an idea how I would start it. When you start drawing a shape, whatever the properties are, you can just store the properties. So you're going to have a couple properties off the top. Color and is fill. are basically the properties you're going to care about. So it'll be this dot color equals COL. This dot is fill equals is fill. I know it's not good form to have the parameter the same name, but and this will basically say whether or not you're drawing a line or whether or not you're drawing you're filling the object. Now, filling the object can be a little challenging depending on what you're doing. If you're doing the N shape object, you're going to want to use, what are you going to want to use? What are our WebGL primitives? Triangle, line, fan, well, not triangle fan, but points.
Small children tears?
What?
Nine
Small
small.
children tears? Broken dreams?
Yes.
Triangle strips?
Triangle strip. That's the one we're looking for. So in Polygon, it makes the most sense to have a triangle strip, and you just add triangles to whatever shape you're making. You get a really nice, you make a really nice dynamic shape. If you're doing a circle and you're doing fill, you're going to want to not include the initial point, because otherwise yeah, I'll let you figure it out. You do have to have the initial point, but you're going to want to use triangle fan if you're doing a circle. So I click here, go here. I'm going to have to calculate a bunch of points around the circle, and then I have to make sure I add the second point twice at the end, or once at the end as well, so I get a full circle. And then I want to use triangle fan to fill in the circle. If I'm using triangle or rectangle, I can use just the GL triangle. Likewise, if it's not going to be filled, if this is set to false, then I'm going to have to use just use line loop. I feel like we need line strip. I guess you would need line strip for the draw line, but then after that, all the shapes themselves are going to have just a line loop. So you have the loop of the shape. And don't worry, your circle is going to look like a Pac-Man because so technically when you're drawing the circle with outline, you don't want to include the first point because it'll look like a Pac-Man at that point. Your circle will go around and it'll go into the center. So all the different shapes are going to have a little bit different situation based on the current context. So you're going to have to kind of think through this. So I'd recommend having a class for each individual shape. All classes are really going to have just the two initializers will be the color and whether or not it's going to be filled. And this will be sent in from whatever the current setting is when you have started creating a shape. Now I would have an array called this.vert, and we're going to be using this a lot during our time. And then you can go ahead and create the buffer. So this.buffer equals new GL buffer. I'm not going to actually give you all the code, but you don't have to buffer the data right now because there's no data. Actually, I take that back. You will have. No, you can do this. You can do this on a different point. And then you're probably going to want to have a variable to know whether or not this shape is finished. So this is drawn, and by default will be false. Once the shape is finished, then we know we don't have to rebuffer it every frame. So this variable is going to determine whether or not we're actually done drawing that current shape. Now, we'll have a function called add point. And this will just simply add a vertex to the buffer. And so once we do this, we can say this dot vert dot push. I would take advantage of the push. And then X, this is going to be a single dimensional array, and this dot vert dot push Y. Because you remember, right, our vertices were a single dimensional array that we were using to mimic a 2D array. Now at this point, this means I've added a point. At this point, this means we want to determine whether or not our shape is drawn. Usually, except for the end polygon, the second click will finish the shape. So if the first click, I take it back. Yeah, so we want to know whether or not our shape is drawn. So if it's a circle, the first click's the center, the second point is our radius, and we have to calculate the points around the circle. If it's a rectangle, the first point is the coordinates. The second point is the first point is the top left. Second point is the top bottom right of the rectangle, and then on the second, when I click on the second right, we know we're done. So that's why I have broken these up into individual classes, because now I can deal with this in particular for the rectangle. So I can check and say if this dot vert dot length is equal to, I think it's capital L, but I'll let you figure. It's lowercase L, okay. Been stuck in C# too long. Vert dot length is equal to, say, 2 times 6. Now why would it be 2 times 6? Two vertices, why 6? A rectangle has 6 sides, huh?
I don't remember.
Nope, that's not it.
Yeah, it says six.
A 3D one has 6 sides, but a 2D one has 4 sides.
Yeah. I was thinking about a 3D one with six.
So why would I multiply with 6?
Oh, is it because each of them is an X, Y, Z, and then 3 color variables?
Perfect, you got it. So when I add, and I cheated here, I made a mistake here on purpose. I have to actually add the Z value, and then I have to add my color values. But yeah, I'm going to want to, and you could store the colors as an array if you want, like I'll let you figure out how to do that. But each vertex is gonna have 6 values to it. So once I have 12 values in my array, I know I have 2 vertices. And if I'm drawing a rectangle, I know I'm done. Or if so let me fix this real quick. We have this dot vert dot push. For now, Z can be 0, I believe. Yeah, Z can be 0. So that's my Z value, and then I have to push this dot vert dot push my color, which you have to figure out how to represent this one on your own. Like this is, because the color coming in from HTML is going to be a hex value. You can break up that string. So I'll let you figure out how to do that. I think there's also a color selector. Some people were using a color selector, and I think if you call back, you give it a JavaScript callback to onValueChanged, I think it will send you an array of RGB. But I don't think it's between 0 and 1. So just remember that this has to be an array of RGB between 0 and 1, and you have to figure out. I'll leave that to you for experimentation how to get that from the web browser. So after I push this, now I push 6 values. If I have 2 times 6, in this case it'd be 12, then I know my vertex is finished. So I can say this dot is drawn equals true, and then I can buffer my data for the last time. Now remember, when I buffer the data, I need to load or bind the buffer of my current buffer I have up here, and then I can do buffer data on it. Once I do this, I will not have to buffer data anymore for the shape. It'll just be a shape stored in objects. And I'll post this on Canvas because this is just pseudocode. If this was a circle now, it would be done as well, but I now have to go through and make sure, I only have 2 points, but now I have to calculate, okay, here's my center point, and now I have to add points around the circle. I don't know, make it 25 points. So I can do a for loop. I can do, or just 25 points around the center, and then add those to my vertices. If I'm doing an outline for the circle, I want to remove the center. So when I do line strip, it'll be an outline of the circle. If I'm doing a line fill, I want to add the second point, so this point here, twice, so it'll fill back to the very beginning. Otherwise, I'll end up with like a wedge Pac-Man looking shape. Which that happened to you guys. So even though the shape only takes 2 clicks, it doesn't mean you're only going to have 2 vertices. It just means it only takes 2 clicks. Does that make sense? And you may want to make that portion of it, a separate function for the circle, because you're going to have to call that while you're moving your mouse back and forth. That makes sense. So on the render side now, unfortunately, there's a little bit of a reuse of code here, but so if this dot is drawn is true, then you're going to render this shape normally. So you're just going to bind the buffer, set your attribute pointers, and render. Okay, so if it's already done, you just render it. You don't need to worry about doing anything extra. If it's not already drawn, then I have to draw an outline as if I was that current mouse position was the last that point I'm looking for, or the next point in the draw. So I'll be honest with you, it's worth your while for this project to get this part working first, because I think if you don't get the cursor drawn, I think it's like only minus 15 points. So it's, or maybe 10 points, I have to check the rubric. But get the thing to draw, and then then you can worry about the cursor. But this is kind of how I would set it up. So for the case, it's like else, it's not actually drawn yet. So I want to temporarily add a point to the, so I can say this dot vert dot push global mouse x. This is my mouse x variable that I would make. Again, this is pseudocode. This is not real code. This dot vert dot push global mouse y, this dot vert dot push 0, that's my z value. I could this dot vert dot push 0, 0, 0, basically to get, because I don't care about the color right now. So now I'm going to temporarily add these three, these six for their values. So now whatever the mouse is currently located at, then that's going to become a temporary point. Now, while I'm drawing it, I have to render the function. I have to bind a buffer. So bind buffer, and then I have to buffer data. Normally, we don't want to do this in our render function, but because the shape, the vertices themselves of the shape are changing, I have to buffer the data. I can't get around this. Then I can just render GL line loop, or line loop. Unless it's a line, then you can just do GL line, but or line strip. I guess line strip would be better for GL line, or for the line function. But otherwise, it's going to be a line loop, and then I'm going to render it with as if this was the current values in vertices. After that, I'm going to pop off those 6 values, and then I'm going to move on with life. So this dot vert dot, I could probably just, I have to remember, so for I equals 0, I is less than 6, I plus plus.
I have to do bar I.
Yes, I know.
Sorry.
Then I could do this dot vert dot pop 6 times. So now I've removed the fake vertice I added. So your render is going to have 2 modes. If you finish drawing the shape, you just draw it. Otherwise, you're going to have to just draw the outline. Does that make sense how to approach it? Yes. Again, just really try to plan this one out before you start writing code, because you can easily end up with 50 to 100 pages of JavaScript with nothing working. It shouldn't be that long. Like, you should probably, your end polygon and your circle are going to be the largest functions. Everything else should be about less than a page as far as a class. And then your web page is going to look very similar to what to this demonstrate to the modular input demo, except that you're going to have some variables stating what the current color is, whether or not it's outlined, what the current shape is. But apart from that, it's going to be really close to what you already have there. So you shouldn't end up with tons and tons of code unless you're doing it incorrectly. Now, this is only half the battle, though. I don't know why I expected that to run. For some reason, I was going to run that, and I'm like, well, it's not real code. Nope, that's not what I want. Oops, that was supposed to be shape, not shape W. But. All right, so what I would do now is on the key press, write to some of this. I would check to see if the last element of objects, so we'll just change this to objects real quick. So check to see if objects.size is 0 or the last element in the objects is actually m dot objects dot length equals 0 or m dot objects bracket m dot objects dot length minus 1 dot is drawn is false. Yeah. So I'm going to check to see, do I have any objects in my array? If I don't, I'm drawing my first object. Otherwise, I'm going to take the last object, and the way I access the last object is take the length of the object minus 1. Remember programming 1, the last valid element is size of array minus 1. So this will give me the last element, and if this is currently being drawn, then I'm going to have to add that point, so to speak. Add the this is key down. I'm sorry, it's not the right. This is not the right function. Hold on. Here we go. So in the mouse down, not key down. So if the last object is not drawn, or I'm sorry, no, if this is true, so if it is drawn, there we go. So if it is drawn or the size is 0, that means I need to create a new object. So here I'm going to have to say m.objects.push new, and in here I may have a switch statement, see if it's a circle, if it's a rectangle, whatever I'm trying to push. So new shape, we'll call it rectangle. And in here we can pass in the color and the whether or not it's outline or is filled. So we'll send in true. Okay, but this is so we'll switch on what shape is currently shape is selected. And this would be case rectangle. And you can use numbers as well. So I'm going to create the new shape. So either the list is empty or the last object has been drawn. I'm going to create the new shape, and then I'm going to add the point that I just stated. So my my objects dot or bracket my objects minus 1, because I just added this one, dot, and say insert point. Is that what we called it? Add point. Add point, and then x and y from the variables I found up above. So here, if the list is empty, or if the last object in the list has been finished, it's been drawn, then I'm going to say, go ahead and create the object, and go ahead and point that we just found, just added that point here. And this is for the rectangle, obviously, if it's a circle, we have to add a new circle, if it's a triangle, we have to add a new triangle, etc. Any questions with that? All right. And then, else, what do we do for the else? The else is actually really easy. One line of code. Think about algorithmically. Don't think about like the exact WebGL-ness. Think about like, what are we trying to do? If that first statement is true, I'm starting a new shape. Whether the shape list is empty or whether I have or whether, yeah, the last object I've done is drawn, I'm starting a new shape here. If this is false, then what's happening down here? Just adding another point. So, and then we let the class deal with whatever happens after that. So we can say, m.objects dot bracket m.objects dot length -1, because we know it'll be the last object on the list, dot add point x, y. And then we're pretty much done with our user input, because we're gonna let each of our individual classes deal with what happens when I add the point to it. Does that make sense? Yes.
Why do we add another point when this one is true and when it's false?
Sorry, is drawn is supposed to be true here. I originally had fault. It's supposed to be true here. So if the last object is drawn, if it's finished,
Why do we add another point to it if it's finished?
Cause that's part of the next new one.
oh no, this creates a new shape. So if it is finished, we create a new shape. So if this is false, or if this is true, so if it's 0, but if this is false, then the last object we're currently working on is not finished yet. Does that make sense?
No.
Well, like in the first one, that's the new point is the first point of a new object. In the if it's false, it's just the next point in the same object you're working on.
So here, I'm going to, when I do new or my objects dot push, say I have rectangle selected, I'm going to create, this is a new object. This object here will not be drawn. I'm guaranteed, because is drawn will be set to false by default. This object is not finished. So this object I create here, I'm going to add the point. Not to, and when I push it, that's going to increase the length by 1. So this function here, or this access, or this index here, is going to be +1 to what this index was. Because I've added an element here. I've added a new object to it with push. So I see what you're saying. So yeah, that makes, I understand what you're saying. So I am not adding to this point. I'm adding, like this will be the next object that I just created. Does that make sense?
A little bit, yeah.
Little bit.
It helped if I saw it working.
What?
It helped if I saw it working.
I have an example, a partial example somewhere. I have to dig it up, but we'll see.
Will you post that when you find it?
Maybe. Some of my early WebGL examples I'm not very proud of, so we'll see. But Following, now the cool part here though is, I mean, you're gonna do the same thing for each shape essentially. The only special case will be if I think if you hit the space button or something, or maybe or if you want to do right click, then that means you're going to stop drawing the end polygon. So the end polygon is never going to be is drawn as true until you either hit the right mouse button or a space, and that will signify that you're done drawing that shape. And that will be from a key callback most likely, but this will this mechanism here will work for all the other shapes. Oh, actually, it'll work for end polygon too. It's just this will never be true until you hit a different input for it. Now, rendering is a little bit trickier. So after I'm done, so remember I'm going to have a bunch of different cases here. Etc., etc. I have a bunch of different cases. After I'm done, I know I am not finished with my shape. That means I have to call an animation frame or request anim frame, so I can then reanimate my frame or reanimate my shapes and have my outline appear. If I do not have, if my last object is drawn, is finished, then I do not need to do a request animation frame. Sorry, what? So, here, so after I've started the shape, then I can say, after the switch, I can do, okay, request render, whatever I'm gonna render. Now down here, I do not know if, after I've added the point, if the shape is finished or not. So I need to check, I need to say if m.objects bracket m.object, the last object in the array, which it should exist because I don't think I can get to this access point without it existing, is drawn. That means the point we just added, finished the object. So, or sorry, opposite, equals false. So what that means is the point that we just added did not finish the object. So we just added a point to this and did not finish. It means it's probably either A, it's a triangle, or B, it's the end polygon. The triangle will take 3 points, the end polygon will take n. So if that is true, then we want to, or if this is false, if it's not drawn, we want to request the animation frame again. Yeah, so here we do the request animation frame for it to redraw. I'm trying to think if there's an easier way of doing this. Hold on, let me think. I think there might be an easier way of doing this because this is only going to trigger on input, which you don't want that. You want this to trigger on a but you want it to have it keep triggering. That's the problem. No, I wouldn't do that here. I we don't actually need to do render objects here, or the animation frame here. This is just adding points. We don't need to do, this here. Let me make this a little easier. So after I have this particular function set up, then I want to do I will need some sort of function to handle mouse move to get the global X and global Y. And then what we'll do, let's go up to main real quick. We'll do a render first. So this is going to be our master render. Oh no, I know how to do it. This will be easier. This will be easy. Okay, never mind. I was sort of thinking how to make this happen, but this will be easier. So we'll just have a function render. And then what we're going to do here is we're going to clear the background, or clear background. Then we're going to draw for each of our objects, for each object, and I would not use for each, I would use the C style. So for var I equals 0, I is less than this dot objects dot length I plus plus, because there is a casting problem in JavaScript if you try to just get a generic object. So then we say this dot objects bracket I dot render. This will render each individual shape. And then what we can do is we can say if the last object in the object array dot I dot dot is drawn is false, then we know we're currently just moving our mouse around trying to finish the object. So here we do the request anim frame to this dot render. So this will be the thing that checks to see if I need to animate or not. Because once the last object is drawn, I don't want to request the animation frame, so this just gets rendered and everything's static at that point. But while I'm drawing the last object, I have to keep clearing the background and going through everything and going through all my objects from 0 to whatever object I'm currently at and render the whole scene. And then if the object is still not drawn, I need to request animation frame and just keep repeating this. Once this last object is drawn, I don't have to request this, and I don't actually render it. I stop rendering. So the render frame itself will check to see if the last object is finished. What we will have to do is go back to our input real quick, and we'll have to say, once I start a new object, so right down here, I will have to request the animation frame. So request anim frame m dot render. So this will initialize the rendering, and the render function in main will in fact disable the animation, or disable the rendering. So this will initialize it. And then up in render function, once I've rendered everything, I'll check to see if the last shape is done. Once the last shape is done, then I will stop requesting the animation frame, and I will not request the animation frame again until I've started a new shape. Does that make sense? So I don't have to, I will not be redrawing while I have not while I don't have an active shape on the screen. That make sense? Okay. So I will post a pseudocode. What time is it? 12:40. Oh, we're done. Okay.
Yep.
All right. So I'll post this online. Use this as a springboard. Again, think about each of the individual objects. All of the most difficult ones are going to be the circle and the polygon.